This is Math 105, section 3.3. We're talking about dividing polynomials in this section, but we're starting to look at polynomials from an algebraic standpoint, so we're going to study polynomials algebraically. So we're going to talk about factoring polynomials, okay, which we've done already. We know we factor quadratics. But in this case, we have higher degrees, higher than 2. We need to know how to divide polynomials. So we're going to work on that, dividing polynomials. Okay. In other words, we're going to take one polynomial divided by another one. Okay. In particular, x minus c, x minus some number. Okay, so when we do long division of polynomials, we start by looking at how we divide numbers. Okay, so for example, if we divide 38 by 7, we see we get a quotient of 5 because 7 times 5 is 35, and then we have 3 left over, and that remainder goes over the 7. Okay, so if we do 38 divided by 7, if we did our long division, the first part that we're dividing up is called the dividend. The part that we're dividing it into is called the divisor. Okay, and then our quotient is our answer, what we get, and the remainder is what's left over. So if we take 38 divided by 7, here's our dividend, here's our divisor, right? We're using our standard long division sign. 7 goes into 38 5 times. 7 times 5 is 35, so we subtract, and we get 3 as our remainder. And we stop because 3 doesn't, we don't have any, 3 is smaller than 7, right? We can't take any more 7s out. Remember, division is just repeated subtraction. So we can take 5 7s out of here, but then we have 3 left over. Okay, so here's our answer. Quotient plus remainder over divisor. 5 plus 3 sevenths would be our answer. Okay, so that's how we do it for numbers. So another way to look at that problem that we just did is that we could say 35 equals 7 times 5 plus 3. Now this is what our polynomial, what we were trying to divide. That's our dividend. This is our divisor, and this is our quotient. So you can see here's divisor and quotient plus remainder. Okay, so we can kind of write it this way, showing it, okay, I tried to factor 35 into 7 and 5, but I didn't quite because I have a plus 3 there. Okay, so this is like the factored part, the dx qx, divisor times quotient, and then the remainder is the part that's left over. Okay, so we can say 35 equals 7 times 5 plus 3, okay, doing that division. And what we're doing is we're taking p of x, the dividend, divided by d of x, the divisor. So we can write it in this form, okay? So just to summarize here, if p of x and d of x are polynomials, d of x is not equal to 0 because we're going to divide, right? We can't divide by 0. Then there are unique polynomials, okay? Q of x, which is our quotient, r of x, which is our remainder, and where r of x is either 0, or if it's not 0, it's of degree less than the degree of the divisor, okay? So you can think of, like, in number terms, our remainder has to be less than our divisor, right? Like the 3 has to be less than the 7, Here we say it has to be lower degree, okay, or 0. Okay, so it can't be the same degree or higher. It has to be a lower degree. Okay, so that's when we stop, is when our remainder is of lower degree than the divisor. Okay, so this is our form here, p of x equals d of x times q of x plus r of x. Okay, so p of x is the dividend. Okay, d of x is the divisor. Okay, q of x is the quotient, the answer, and r of x is the remainder. And the reason we're using x because now we're talking about functions of x. So these aren't necessarily numbers; they might be expressions involving x. Okay. Okay, so now let's look at long division of polynomials. Okay, so we're going to divide 6x squared minus 26x plus 12 by x minus 4. Okay, in this case, we're always going to be dividing by x minus some number or x plus some number. So it's going to be just a polynomial of degree 1. Okay, basically, we're going to have an x term. Okay, nothing else, not an x squared. So x minus 4 or x plus 2 or something like that. Okay. So our dividend is what we're starting with, 6x squared minus 26x plus 12. The divisor is x minus 4. So let me just kind of mark that in. The dividend is this, that quadratic. Divisor is the x minus 4. And using our long division, our kind of traditional long division, we would put, the divisor here and the dividend here. And now we want the leading term in the dividend to get the first term. So we're going to take this term times whatever to get this term, okay? So if we multiply this times 6x, we're going to get 6x squared, okay? So that's our first step, is to multiply the x minus 4 times 6x. But we have to multiply both both parts times 6x, but we're trying to get rid of this thing term by term. So we start with this term and say, okay, x times 6x gives us 6x squared. Okay, so here's the 6x, and then we multiply the 6x times both of these to get 6x squared, and this becomes minus 24x. Okay, now we subtract, remember, just like we do with the numbers. So subtract, this cancels, right? If we subtract here, we have minus 26x minus a minus 24x, which is a plus 24x. So that gives us a minus 2x. We're subtracting, right? And then 12 minus 0 is just 12. Okay, so our next step is that we have this minus 2x plus 12. We're going to multiply the x times minus 2 up here to get that minus 2x, because we're going to try and cancel that term out. Okay? So here's the minus 2, and we have minus 2x gives us, minus 2x, right? And then minus 2 times minus 4 gives us a plus 8. Here we're subtracting, so these cancel. 12 minus 8 is 4. Okay, so here's our quotient, 6x squared minus 2, answer. Here's our remainder. Okay, so the division process ends when the last line is of lesser degree than the divisor. Okay, and then the last line is the remainder. Okay, the top line is the quotient. Okay, so we stopped when we got the remainder of 4 because it's of lesser degree than the x minus 4, right, which was our divisor. Okay, so here's our dividend, the thing we started with. Here's what divided by, the x minus 4, the divisor. Here's our quotient, 6x minus 2, plus remainder over divisor. Okay, so that's how we could write that. Okay, now here's another way to write that. Okay, we could write it as, now this is kind of the first way we did the long division. Here's our answer, and here's our remainder divided by divisor. But using the other way that we looked at, we could say, okay, that means this thing we could write as x minus 4 times 6x minus 2, right, plus the remainder. Okay, so that's the way we're writing dividend equals divisor times quotient plus remainder. Okay. So that's the other way of writing this, doing the division. Okay, an alternative way of doing this is called synthetic division. This is kind of a quick method of dividing polynomials. It can only be used when the divisor is of the form x minus c. Okay, I just put x minus c together there. So we have to be dividing by x minus 2 or x plus 1 or something like that. If it's x plus 1, your c would be minus 1. Okay. So basically, we're only going to write the essential parts of the long division. Okay. So here we're going to divide 2x cubed minus 7x squared plus 5 by x minus 3. Now we're only going to use the coefficients and the c when we do our long division. So we're not going to put the x parts. The x is there. We'll put just the coefficients. Okay, so let's start with the long division. We're taking 2x squared minus x minus 3 over x minus 3. So the first thing we can do is take the x and multiply it times 2x squared to get the 2x cubed, right? Because we want to cancel that out. So we multiply 2x squared, and we get 2x cubed, and then we have to multiply times the minus 3, so that gives us minus 6x squared. Okay, so subtract, this cancels. Minus 7x squared minus a minus 6x squared gives us, remember that's plus 6, if we subtract a minus, that gives us minus x squared. Okay, our next step is to multiply x times minus x, so we get this minus x squared here. Okay, so, and then we also have to multiply the minus 3 times minus x, so that gives us the plus 3x. Okay, make sure you put a 0x there, okay, because you need that place value. Okay, you need the x term because we're going to subtract it, right? So even though we don't have an x term, put a 0x in there. So we have, think of this as like, this is like our ones place, our tens place, our hundreds place, our thousands place. We need every place value in a number. Same idea here. You need every exponent on x. X to the 0, x to the 1, x squared, x cubed, up to your highest degree. So put that 0 there. Now we subtract. So we have minus x squared minus a minus x squared cancels. 0 minus 3x gives us minus 3x. Okay, and then our last step is to multiply x times minus 3 to get this minus 3x. Okay, so when we do that, we get minus 3x, and we also get a plus 9. Okay, now we subtract. 3x is cancel, minus 3x is cancel, and 5 minus 9 is minus 4. So here's our remainder. Okay. Now, what does that tell us? That tells us that this x minus 3 is not a factor of 2x squared minus x minus 3, which is what we're really concerned about. And the reason for that is because we have a remainder. If our remainder was 0, we could say it is a factor. We could divide it out. Okay, now let's look at synthetic division. Synthetic division, you're doing a similar thing, but it's actually much quicker. You're going to put your coefficients only in this thing, okay? So our first coefficient is 2, right? And then our next one is minus 7 for x squared. But we got to put the 0 for x because we need the x place there. So we'll put a 0 here, and then we put the 5 here, okay? And then on the outside, now we're going to put a box like this, so it's kind of like an upside down division in a sense. You know, we put this box here. And then we put the c there. If we're dividing by x minus c, our c would be 3, okay? If we were dividing by x plus 1, here our c would be minus 1. So it's x minus c, and the c goes here, okay? So that's our setup, is we put the coefficients here and then the c here, okay? Coefficients of the dividend, okay? And then the first step we do is always bring the 2 down. Okay, so that always gets brought down. Okay, just carry it past that line and just put a bar underneath, and then it gets carried down. Okay, the next step we do is multiply. Okay, so we're going to multiply this 3 times this 2. Okay, and then put it here. Okay, so we're doing this. We're going to multiply. I'll put a little dot for multiply, and then we're going to add here. We're going to put it there. Okay, and then we add. Okay, so we multiply and put it there. Okay, and then we add. So minus 7 plus 6 is a minus 1. So we always add there, not subtract. Okay, and then we do it again for the next step. So we're going to take 3 times a minus 1 and then put it here. Okay, see, we did 3 times 2. We put the 6 there, right? We're going to take 3 times a minus 1 and put it there. And then finally, we're going to take a 3 times a minus 3, which is minus 9, and put it there. Okay. And then notice we're always adding here vertically. So 0 plus 2 is 2. 2 plus 0, yeah. Minus 7 plus 6 is minus 1. 0 plus a minus 3 is minus 3. And then 5 plus a minus 9 is minus 4. Now we are done. Okay. This gives us our answer. Okay. It actually gives us the coefficients. The last column is our remainder. See, the remainder is the same. And then the next 3 are our coefficients. So this would be our x to the 0 term, okay, is minus 3. Our x to the 1 term is minus 1. And our x squared term is 2. So it doesn't, you know, we don't have the x's there, but it gives us the coefficients of our quotient. Okay. So this would be 2x squared minus x minus 3. We're always going backwards, so this is going to be our number part. This is our x term. This is our x squared term. If we had more, we'd have an x cubed, etc. Okay. This is our remainder. Okay. Well, this is the important thing, because we see a remainder, we know that x minus 3 is not a factor of 2x squared minus x minus 3, as we see. So once you get the idea of doing this, it's much quicker than doing the long division. You know, the convention for doing this, it's much quicker. Okay. Now this only works when we're dividing by x minus some number, like x minus 2 or x plus 1. Okay. So we're just writing the coefficients there, here. Okay. And then we're putting our c there and following that synthetic division algorithm. Okay, so just a quick recap. We're dividing 2x cubed minus 7x squared plus 5 by x minus 3. So we start by putting our coefficients there, and we have to have a 0 for x. So our 5 here, then 0, then minus 7, then 2. Okay, there's our coefficients. Okay, and then put the x minus 3. Here's our c. Remember, we're dividing by x minus c. Okay, and we're doing that because c is a 0, right? Think of, you know, c is, well, if we plug in c here, we'll get a 0, and that would be a 0 of our polynomial. So we'll put the c here. Okay. Okay, the next step we do is bring the 2 down. That first column we bring down. Multiply, put the 6 here, and then add. Okay. And then we do the same thing with the next column. Multiply, put the minus 3 here, and then add. Okay. And then finally, we just do it with that third column. So 3 times a minus 3 is minus 9. Put it here, and then add 5 plus a minus 9 is minus 4. So remember that last column we get is our remainder. And this is our quotient, 2x squared, coefficient of x squared, minus x minus 3. Okay. So that's our quotient. We saw that from doing the long division. Okay, so we can say 2x cubed equals minus 7x squared plus 5 is equal to x minus 3, our divisor, okay, times the quotient, 2x squared minus x minus 3, our answer, plus the remainder, which is a minus 4. So there's minus 4. Okay. In other words, this thing is not factored by this, right? Because we have this remainder. So x minus 3 is not a factor of that because of the remainder there. So we will look at both methods in class and kind of compare it just like we did here. We'll look at a specific example and use both methods. You know, I think it's helpful if you haven't done synthetic division before to learn it because it's much quicker when we're trying to figure out if something is a factor of, you know, whether, you know, x minus 2 is a factor of our polynomial. Okay, because that's kind of what we're doing is we're looking at small factors like x plus 1, x minus 2. And then we'll look at some other things that theorems that we can use to determine whether things are factors as well. So we'll do that next. So let's start with the remainder theorem. We're going to take a polynomial p of x and divide it by x minus c. Okay? When we do that, the remainder is just the value that you get when you plug in c into the polynomial. Okay? So that makes it easy to determine if you have a remainder or not, because you just plug in the c into your polynomial and that gives you your remainder. Okay, so that's what remainder theorem tells us. Okay, so let's say this is our polynomial. 3x to the fifth plus 5x to the fourth minus 4x cubed plus 7x plus 3. I have a degree of 5, right? Okay. You know, it'd be hard to factor that just on inspection, but we can see, first of all, let's see if x plus 2 is a factor, okay? In other words, we're going to look at the remainder when we divide by x plus 2, okay? Now, we don't have to divide by x plus 2 to see the remainder, okay? We can use the remainder theorem by doing this. Now, remember that form is x minus c, right? So here our c would be minus 2, okay? So we're going to plug in that c into a polynomial and see what we get. Because if we get, whatever number we get is going to be our remainder when we divide by x minus c or x plus 2, okay? Okay, so if you plug in minus 2 into this polynomial, we get this. P of minus 2 is 3 times minus 2 to the fifth. Make sure you use parentheses in minus 2 because that's where our x is, right? Plus 5 times minus 2 to the fourth. Minus 4 times minus 2 cubed. Plus 7 times minus 2 plus 3. Okay, so minus 2 to the fifth is minus 32. Minus 2 to the fourth is plus 16. Minus 2 cubed is minus 8. And 7 times minus 2 is minus 14. And then plus 3. Okay, so this is minus 96. 3 times minus 32. 5 times 16 is 80. Minus 4 times minus 8 is plus 32, minus 14, and then plus 3. And when we add all these up, we get a 5. Okay, so that's our remainder. So this is what we would expect to get based on our remainder theorem. If we divide by x plus 2, we should get a remainder equal to 5. Okay? In other words, we can also say that x plus 2 is not a factor of this because our remainder is not 0. So we can determine that we can't divide x plus 2 out of this perfectly. But we should expect this to be our remainder when we divide by x plus 2 based on our remainder theorem. You know, we're plugging this in. Okay, so let's look at that in the next slide. Okay, when we're dividing by x plus 2, our c is minus 2 because remember it's x minus c. So here's our c, so we put our c here. Here's our coefficients. 3 from before, 3, 5, minus 4, 0, 7, 3. Remember there's no x squared term, so we have to put a 0 there for x squared. Okay, remember it's 3x to the fifth plus 5x to the fourth minus 4x cubed plus 0x squared plus 7x plus 3. Okay, so that's our coefficient from before. Okay, now remember we start by bringing down the 3, and then we multiply minus 2 times 3, put it here, and add. Okay, multiply minus 2 times minus 1 is 2. Put it there, and we add. We get minus 2. Minus 2 times the minus 2 is plus 4. Put it there, and we add. Minus 2 times plus 4 is minus 8. Put it there and we add, so that gives us minus 1. And then finally, minus 2 times minus 1 is plus 2. Put it in the last column, and then we add, and we get 5. Okay, so there's our remainder of 5. Okay, we can see, there it is. That's what we're looking for, right? Here's our quotient. Kind of reading backwards, this is just the minus 1. This is 4x. Okay, this is minus 2x squared. This is minus 1x cubed, or minus x cubed. This is 3x to the fourth. So remember, the rest of this gives us our coefficients, starting from, you know, this would be the highest term, right? This is the lowest, so this is going to be minus 1, 4x, minus 2x squared, minus x cubed, and then plus 3x to the fourth. There's our quotient. Okay, the next thing we'll look at is our factor theorem, and this kind of goes hand in hand with the remainder theorem. That says this. Our factor theorem says, if c is a 0 of p, in other words, we plug in c, let's kind of define that again. C is a 0 of P means P of C equals 0. Okay, so that's another way of saying that. If and only if X minus C is a factor of P. Okay, so think of, we can say this. I'm going to use this kind of notation, but I'm going to use this arrow like this, and this is symbolic logic, but we can say X minus C is a factor. Okay. Now remember, when we say P of C is 0, that means R of X, the remainder is 0 when we divide by X minus C. Okay, so that's according to our remainder theorem, that we're dividing by X minus C and we get a remainder of 0. Okay, which does mean that X minus C is a factor. So it kind of makes sense based on what we did with the remainder theorem. But the important thing is that these go hand in hand. That if you have a 0, then X minus C is a factor. So if 2 is a 0 of your polynomial, in other words, you plug in 2 and you get 0, P of 2 is 0, that means X minus 2 is a factor of that polynomial. And then when we divide by X minus 2, our remainder will be 0. Okay? If it's a factor, your remainder has to be 0. Okay? So these two things go hand in hand. If C is a 0P, then X minus C is a factor, and the vice versa. If X minus C is a factor, a polynomial, then C is a 0. Okay, so that's what that if and only if means, that they both happen together. Okay, so let's say, for example, our polynomial is x cubed minus 7x plus 6. Okay. First of all, let's show that P of 1 is 0. Okay, so we're going to plug in 1 and see what we get. Okay, so P of 1 is 1 cubed minus 7 times 1 plus 6, which is 1 minus 7 plus 6, which is 7 minus 7, which is 0. Okay, so our P of 1 is 0. That means X minus 1, by the factor theorem, this means that X minus 1 is a factor of P of X, which means we can divide out X minus 1 to factor this thing. So let's look at the long division first. I have x cubed, remember you have to put a 0 for x squared, minus 7x plus 6. We're dividing by x minus 1. So the first thing we do is take x times x squared to get the x cubed, and then we take minus 1 times x squared and bring that over 2. So subtract. 0 x squared minus a minus x squared is a plus x squared. Okay. Then our next thing is to take x times x to get that x squared there. Okay. And then we have to take x times minus 1 to get the minus x there. Okay. So remember, we have to multiply this times both of these and put it down here. Subtract and we get 0 there. Subtract here, minus 7x minus x gives us minus 6x. Okay. And then we don't forget to bring that 6 down, right? Because that still has to be carried down. Okay, so we have minus 6x plus 6, and 6 times x times minus 6 gives us that minus 6x. Okay, we multiply minus 6 times minus 1, we get the plus 6 there. Okay. So now we subtract, and we see we get a remainder of 0 because these cancel out. Okay, so that's how we get our remainder of 0 there. Okay, but here's our answer. X squared plus x minus 6 is the other factor. See, because we factored this out. Okay. Now, using long division, that is that way, but using synthetic division, we just put our coefficients in, right? So here's 1, 0, minus 7, 6 are our coefficients. And then we're taking x minus 1, so we put the 1 here. Remember, it's always x minus c there. Start by bringing the 1 down. Multiply. 1 times 1 is 1. Put it there and add. 1 times 1 is 1 again. Put it here and add. Get minus 6. 1 times minus 6 is minus 6. Add, we get a 0. You can see there's our remainder, and these are our coefficients of our quotient, right? So minus 6 plus x squared. So synthetic division is quicker. It gives us these, our answer much quicker. If you get confused, you can use long division, but if you're trying to find factors, kind of synthetic division is the way to go. It's much quicker. And we're always dividing by x minus some number, so we're just going to put that number there. X minus c, there's our c. Okay, so now we can write our factorization of this because we factored out at x minus 1 and we got a quotient of x squared plus x minus 6. So we can say this polynomial of x cubed minus 7x plus 6 is quotient times divisor, right? So x minus 1 times x squared plus x minus 6. So we partially factored this, right? We factored out the x minus 1. Now the last step is just to factor out this thing, right? This quadratic, which we can do, right? That's just x minus 2 times x plus 3. So that's the full factorization of that. Okay. So we factor out the x minus 1 first. We can see if x minus 1 is a factor by plugging in 1 and see if we get 0. Okay. And then if we know that that's true, then we can divide out the x minus 1. There's our quotient. We just have to factor our quotient out, and we're done. Okay. So notice we have 3 factors here, right? Because we have a degree of 3 on this polynomial. Okay, we'll look at some examples in class, maybe higher degrees, and then in future sections we'll look at how you can find those zeros, what numbers you can pick. So